A queue is a linear list in which data can only be inserted at one end, called array, and deleted from the other end, called the front. For example, data input as 1, 2, 3, 4 and would be removed at 1, 2, 3 and 4. In other words, a queue is a first in first out. Here are some examples of a queues. A queue of people and a computer queue. We have many queue operations, but there are 4 basic queue operations. The first is the queue operation, which creates an empty queue. The second is a queue operation, which inserts an item at the rear of the queue. The third is the dequeue operation, which deletes an item in the front of the queue. And the last one is the empty operation, which checks the status of the queue. This operation returns true if the queue is empty and false if the queue is not empty. Queue entity. Entity is abstract data type, a list of data items in which an item can be deleted from one end, called the front or head of the queue, and an item can be inserted at the other end, called the rear or tail of the queue. Queue applications. Queues are one of the most common of all data processing structures. They are found in virtually every operating system, network, and in countless other areas. For example, queues are used in online business applications such as processing customer requests, jobs, and orders. In a computer system, a queue is needed to process jobs and for system services such as principles. Queue implementation. The first is array implementation. It can be implemented using an array. In the array implementation, we have a record with 3 fields. The first field can be used to store information about the queue. The second is linked list implementation. It can be implemented using a linked list. We have an extra node that has a name of the queue. This node also has 3 fields: a count, a pointer that points to the front element, and the pointer that points to the rear element.
A tree includes a finite set of elements called nodes or vertices, and the path connects pairs of the nodes. It asks if the tree is not empty, the nodes that have no incoming act is root. We can divide the nodes in a tree into 3 types: the root, leaves, and the internal nodes. Next part is subtree. You guys must know that a subtree can exist for each node in a tree. Here is an example. So you guys see that subtree B has B and B's children. Subtree C only has C, and subtree D has D. D stripe is G and G stripe is H. So we have conclusion that the subtree of each node includes one of each children and all descendants of that tribe. The next part is binary tree. A binary tree is a tree with no more than 2 subtree per node. Or you guys can easily know that a node can have 0, 1 or 2 subtrees, and it is example to show which is a binary tree and which is not a binary tree. The next one is binary tree traversals. A binary tree traversals necessitates processing each node of the tree once and only once in a predetermined sequence. Deep first and breadth first traversal are 2 general approaches to the traversal sequence. First is depth first traversal. If we have a binary tree that includes a root, left subtree, and right subtree, so we can define 6 different depth first traversal sequence. But there are 3 sequences have been given standard name by computer scientists: is pre-order traversal, in-order traversal, and post-traversal. First one is pre-order traversal. In pre-order traversal, the root node is processed first, followed by the left subtree and then the right subtree. Next one is in-order traversal. In in-order traversal, the left subtree is processed first, then the root node, and finally the right subtree. The last one is post-order traversal. The right subtree and left subtree process at the same time, and the root process last. The next part is breadth first traversal. In breadth first traversal of a binary tree, we process all the nodes in this generation before proceeding with the next generation. Now we move to binary tree application. In computer science, binary tree have a wide range of applications, but we mention only 2 of them: Huffman coding and expression tree. but we will go over Huffman coding in depth in chapter 15, so I will go straight to impression tree. There are three different ways to represent an arithmetic expression: infix, postfix, and prefix. The operator before the two operands in prefix notation. The operator appears after each two operands in postfix notation and appears between two operands in infix notation. Next is binary tree implementation. Binary trees can be implemented using arrays or linked lists. Linked list implementation is more efficient for deletion and insertion and is more prevalent. The next part is binary search tree. A binary search tree is a binary tree with an additional property. Each node's key value is greater than the key values of all nodes in each left tree and smaller than the value of all nodes in each right tree.
A stack is restricted linear list which all addition and deletion are made at one end top. If we insert a series of data into a stack and then remove it, the order of data is reversed. This reversing attribute is why stacks are known as last in first out. Any situation in which we can only add or remove an object at the top. The next one is operation on stack. Although we can define many operations for a stack, there are four basic operations: stack, push, pop, and empty. The first is stack operation. The stack operation creates an empty stack by using the stack and stack name. The stack name is the name of stack to be created. This operation returns an empty stack. The second one is the push operation. The push operation inserts an item at the top of the stack using push stack name and data item. Stack name is the name of the stack and data item is the data to be inserted at the top of the stack. The third one is the pop operation. The pop operation deletes the item at the top of the stack by using pop stack name and data item. The final one is the empty function. It's used to check if the stack container is empty or not. They will return two value is true or false. And now we will go to the next part is stack IDT, which calls stack abstract data type. Stack IDT is a list of data items that can only be accessed at one end for the top. Therefore, operation of stack IDT are stack is used to create an empty stack, push used to insert an element at the top, pop let the top element is empty. It checks the status of the stack. Stack application can be classified into four types: reversing data, pairing data, corresponding data usage, and backtracking step. For example, to reverse a word, you push a given word into a stack letter by letter and then pop letter from the stack. And another example is reversing data item. The app called decimal to binary. First, they create an empty stack and then use the while loop to create the bit. We push them back into a stack. When all bits created, we exit the loop. Now we use another loop to pop the bits from the stack and print them.
Graph basics. Before we try into interesting graph algorithm, let's first clarify the naming convention and graph properties. A graph is a data structure where nodes can have zero or more adjacent elements. The connection between two nodes is called edge. Nodes can also be called node verticals. The degree is the number of edges connected to a vertex. If the edges are bidirectional, then we have a directed graph. If the edges have a direction, then we have a directed graph, or D-graph for short. You can think of it as a one-way street directed or two-way street undirected. Vertex can have edges that go to itself. This called self-loop. A graph can have circles, which means you could get the same loop more than once. The graph without circles is called a select graph. Not all verticals have to be connected with the graph. You might have isolated loops or even separated subgraphs. If all loops have at least one edge, then we have a connected graph. When all loops are connected to all other loops, then we have a completed graph. Graph application. When edges have values assigned to them, we say we have a weighted graph. If the when is absent, we can assume it's 1. When the graph has many applications depending on the domain where you need to solve a problem. To name a few, for airline traffic, nodes vertical for airport, edges for direct flights between two airports, and wings for miles between two airports. In general, graphs have many real-world applications like electronic circuits, flight reservation, driving directions, social network. Facebook use a graph for suggesting social texting friends. We just learned the basics of graph and some application.